Hey guys, Miss Parasol here. Sorry I couldn't be with you today, but I didn't want us to fall behind. So, yesterday you got some time to practice with your factoring the special cases, the perfect squares and the difference of squares. We're going to see that again today as well. And so you're going to need your textbook. We're going to be on page 425. This is chapter 10, section 5. We're going to talk about factoring completely. And so this is just putting together all the stuff that we have talked about so far. And actually, if you take a look at page 426, this is where we really want, this is kind of our steps, right? This is our go-to place that we want to look at. The very first thing that we want to do, I don't like that handwriting, right? The very first thing that we want to do is to factor out any common monomials. So a GCF, it could be variables, it could be numbers, anything, right? Then once you've done that, or if you don't have to, then we want to take a look at some different strategies, right? From there, actually, let me kind of erase this because we can kind of go in different directions. Let's kind of do this, right? So the very first thing, no matter what, is we want to start, is there a GCF? Okay. All right, then once we've factored that out, then we're going to go ahead and the first thing we want to just check is it one of our special cases? Is it a difference of squares? So does it look like a squared minus b squared, right? Is it like 49 minus x squared? Or maybe it's 4x squared minus 25, right? It has the minus sign, and both the first and last terms are squares. So we want to take a look at that. If the answer is no, okay, let's try a different one, right? Is it a perfect square trinomial? Is it a perfect square? So we want to look, I'm just going to make a perfect square like that. All right, is it a perfect square trinomial? Well, remember, how do we know that? The first term and the last term, not b. The first term and the last term, well, I guess, yeah, it is. The first and the last term are squared. And then that middle term is 2 times ab, right? So, again, is the last term a perfect square and positive? Is the first term also a perfect square? And then if you took a and b and times it by 2, is that the term you get in the middle? Remember, those ones are a little bit harder to kind of notice, but you could try factoring it out and see if it works. And if it doesn't work with that one, then that just means that, okay, well, we just need to then just factor it like we would with a normal trinomial factoring. Okay. And so when we do that, we need to remember, okay, well, does my a value, if my a value equals 1, remember, if my a value equals 1, all I have to do is that mystery number, right? I've got sorry, not a, my c value, right? The two numbers that multiply to give me my c value, but add to give me my b value, right? So let's say we get -5 and +4, right? So then that tells me right there that my answer is x minus 5 and x plus 4, and I'm done, okay? But if we come back and we have a trinomial, but a is greater than 1, we can still do this mystery method, but remember it's a times c. Excuse me. And I apologize for the sound. Working with what microphone I have available to me, which is not the best. Right? And we can factor it out that way. Now remember, we want to do the X box method. All right? And so just reminding ourselves that, let's say we got -5 and 4x this way, right? Let's say it was 2x squared, and let's see, I'm trying to make this up off the top of my head. I can't guarantee that this is going to work. Right? Let's see, -5x and plus 4x. Okay? All right, so remember that now these numbers are what we're breaking the middle term up into. So the original one would have looked like this, okay? And so we're taking this middle term and we've broken it up here, all right? And so once we've done that, then we can look at the box and go, oh, what's the common thing? What do they have in common here? They just have an x. So how do I get to 2x squared? Well, that's got to be 2x. X times what gives me negative 5x? That's got to be negative 5. All right, well, if this is 2x times what gives me positive 4x? Well, it's got to be positive 2. And if we check here, I pulled out a negative 5. Oops, so that probably just means that this should be probably be a negative 10 here if I want to make this work out. Again, I made that problem up off the top of my head. All right, but these are the steps that we want to take and kind of consider. Is there GCF? Is it one of my special cases? If it's not, then we have to go to our normal factoring method, okay? So we're going to take a look at the examples, and then you guys are going to try some on your own, all right? So if we take a look here at, and we also want to check for grouping as well. All right, so let's actually just start with page 426. I know that some of these, oh, no, I'm lying. We'll just go to the example. So we're going to take a look at example 1. All right, and then example 1, they ask you to factor 5a x to the 5th minus 5a x y to the 4th. All right, so again, remember, GCF, check for special cases, and then just our trinomial, let's just call it the X box method, because that method works no matter what your A value is. All right, so the first thing that I notice is I notice a GCF right away. They both have a 5, they both have an A, and they both have at least one X. So I'm going to take out the 5, A, and an X. And that means what's left over, right, if we kind of just go 5AX and 5AX, right? 5 divided by 1, A divided by A is 1, X to the 5th divided by X is X to the 4th. Those cancel out, cancels out, cancels out, and we're left with Y to the 4th. So we did that. But we are not done. Okay, we have to now check what's left over in here. And I actually see a special case, right? If I've got an even exponent, it means it's a perfect square. So, and I notice that it's a difference of 2 perfect squares. So I know that this is going to be x squared minus y squared. And this is going to be x squared plus y squared. And don't forget about this guy that we already have factored out. Now again, you ask yourself, am I really done? Because again, while this is not a difference in squares, I still see another set of perfect squares in here. So I can break this one down even further, okay? All right, so now this can be x minus y, x plus y. I can't go any further with this. It's not a perfect, doesn't have a middle term. Not a difference of squares. It's not, again, because there's no middle term, I can't do that factoring. So I'm just going to leave it alone. And again, don't forget about that guy. And now we have completely factored this. And we could go back and check and multiply it out, and we should get back to where we started if we were to do the multiplying. So we're always, after we do a step, we always want to constantly recheck our work and see any of the factors that are left, can we take it another step further? Okay. All right. Example 2. We have x to the 4th minus 9x squared plus 8. If you're not following along in the book, because I mean, obviously it shows you the steps, but if you're not following along, go ahead and pause the video and try it on your own. Okay, so remember, we're going to check for a GCF. We're going to then check for special cases. And then if the worst case scenario, we're going to go ahead and do the Xbox method. Okay? All right, well, there's no GCF. If this had an X, there would be, but there isn't. 8 is not a perfect square, so this is not a perfect square trinomial. So it means I need to just go to the Xbox method. All right, so I'm going to do that off to the side here. So my A value is 1. 1 times 8 is 8. And I need two numbers that add up to -9. Right? Well, if we write out our factors of 8, here they are. And they can either both be positive or both be negative, but I need them both to be negative because the middle term is negative. So I can see here that -1 and -8 are going to be my factors. All right, so I'm going to go ahead and make a little box. And I'm going to plug in my trinomial, but I'm going to replace this middle one with these two guys here. So x to the 4th, and instead of -9x squared, right, I'm going to put the plus 8 over here. I'm going to now fill in here -1x, and then I'm going to do, oh, it's going to be x squared, because again, notice, pay attention right there. And this is going to be -8x squared. All right, so now we're going to go ahead and do the GCF. So we're going to take a look, GCF here, x squared, GCF here. Now remember, if the one in the lead is negative, we're taking the negative, but let's work backwards just to show how this is going to work out. X squared times what is going to give you x to the 4th? X squared. X squared times what is going to give you -1x squared? Well, -1. Okay, well this is x squared. X squared times what is going to give you -8x squared? Well, it's got to be a -8. And then if we check -8 times -1, yep, gives us a +8. So by using that method, I now have x squared -1, and I have x squared -8. Now again, we have to ask ourselves, are we done? All right, well this first one, that's a perfect square, x squared, and 1 is a perfect square. And it's minus, so it's a difference of squares. So I'm going to go ahead and do x -1, x plus 1. These are not perfect squares, and there's no middle term, so this is just going to stay how it is. And there we are done. All right, so that's your goal as you're working on these. We can take a look at one more, and sometimes, again, for these ones, you might find, and I might run out of time on my video, I have a 15-minute time limit, right? So we take a look at example 3, 2xy minus 7x plus 10y minus 35. This one, remember the last method, is the grouping method. So we can see here these two terms, and we can take a look, and we can use the grouping method as another option, because there's not an all GCF, it's not fitting the standard form. So here we have x, we get 2y minus 7, and then here, what do they have in common? They have a +5, and when we factor that out, we get 2y minus 7, and from there, x plus 5 times 2y minus 7. All right, so hopefully, again, it's all the same stuff we've been doing. You've just got to think through your list. GCF, special cases, the Xbox method, or grouping. All right, so you're going to try numbers 1 through 14 on page 426. All right, I look forward to seeing you guys soon.